Hello, Algebra 2 with Mrs. Krantz. We are solving rational equations. Today's story problems. All right, today is, I think I'm going to post this on Wednesday the 29th. The day that I'm filming this. It's a beautiful day out finally. Sun shining, etc. And I think it's the day that it was officially announced that Ohio would have the rest of their schooling online for the rest of the school year. So this is it, right? All online for about a month more, I think. Maybe, about a month. Maybe a month and a week. All right. Rational equations, and today the focus is SP's story problems, okay? Solving equations. All right. Rational equations have the variable in the denominator, okay? So number one, let's take a look. First problem. The total resistance, R in ohms, for a parallel circuit is given by this equation. Okay, if you're working with me, take a minute, write this down, all right? 1 over R equals 2 over P plus 1 over 2R plus 1 over C. P's 21, C's 12. Find the total resistance, R. Okay? First step. I heard it from the back, I think. Steven said, plug in. 21 for P, 12 for C. All right. So 1 over R equals 1 over P plus 1 over twice R plus 1 over, you got it, Owen, 12. Okay, now what? To solve this equation, do I need a least common denominator? Do I need an LCD? Absolutely, okay? If you have a plus or a minus, you're going to need an LCD. All right. What is my LCD? Oh, can you believe? One's going in for P. 21. Okay. Actually plug them in. All right. Now, what's the LCD? You've got R, 21, twice R, 12. Okay, I don't need a factor, right? I need an R, okay? Then what's the LCD of 2, 12, and 21? All right, 3 numbers. Well, if one of the numbers is a factor of the other number, or the other one, you don't need to think about it really. So 2 is a factor of 12. So really I need LCD 12, 21. Well, here's one method, in case you don't know. What you do is you write your numbers down and you actually, quote, factor the numbers. All right. I said you didn't need to factor, but one way to figure out an LCD is to factor the numbers. All right. Factor them so that you can find the GCF. What do 12 and 21 have in common? Oh, they both have a 3. Okay. And 21 is 3 times 7. 12 is 3 times 4. So you want to factor it so you can find the greatest factor they have in common, GCF. So the LCD will be what they have in common. You need the 3. And then you need what they don't have in common, times 7, times 4, and then of course you need R. All right, so it's 21 times 4R, 84R is my LCD. Okay, now what do I do with that? I'm going to distribute that. I'm going to write it 1, 2, 3, 4 times. Okay, I'm going to write 84R on top of all the fractions. All right, and if we did it right, we will get rid of all the fractions. Okay? 84R times 1 divided by R. The R's cancel. I get 84 equals. Right. Then I've got 2 times 84R divided by 21. Well, 84 divided by 21 would be 4. So I'd have 2 times 4, I'd have 8R. Okay. plus, my r's cancel, and what's 84 divided by 2? I think I heard it, plus 42, no r. And then 84r divided by 12, let's see, 84 divided by 12 would be 7, and that's an r. Okay, now we'll solve for r. Subtract 42, and add your r's. 8 plus 7, 15r. Divide by 15. What's r? Well, we could divide on our calculator. That is 2.8. Okay. 2.8 what? The unit is total resistance in ohms. Okay. Final answer. All right. Now, one other way to get LCD. Do you remember? I want to just review on the calculator. You hit the math button, num, and it's not LCD, it's LCM. Okay? And you can just put in your two numbers, 21, 12. That is another way to get the LCD. All right, so LCM on the calculator. I'll just write that down. All right? This is for the graphing calculator. All right. And you actually can't put more than 2 in, two numbers. You can, but then you have to put the LCM inside of the LCM. All right, if there's more than 2 numbers. All right, now the real story problems, okay? You will not be given an equation, okay? The first thing you do is write the equation, all right? There'll be only one variable, okay? And just think this. When it's a rational equation, the variable will be in the denominator, okay? It has to be. Okay? Like here, our r was in the denominator, all right? So we're going to read these. I think we're going to do 6, so this might take a little bit of time, but stick with me if you can here. Adam travels 40 kilometers in his speedboat. In the same time it takes Will to go 15 kilometers in his not-so-speedy boat. If Will drives his boat an average of 20 kilometers per hour slower than Adam, find the speed of each boat. Okay, that's the main question. Speed. All right. Then we'll answer how long was each person driving the boat. Okay. So who do we have? We've got Adam and we've got Will. All right. What's the variable? Well, we're trying to find speed. Okay. And in math, we usually call that rate. Okay. R. All right. Now, are they both going to be R? Let's see. Will drives his boat, so Will drives 20 kilometers slower than Adam. Okay. Who's going to be R? Well, Adam is going to be R. Why? Well, Will is 20 slower than R. So how do we say that? R minus 20. So say Will is going like 60. Sorry, Adam was going 60. Then Will would be going 60 minus 20, which is 40. Okay. Slower, right? Slower is a subtraction. Okay. Now you're not allowed to switch that around. You can't say 20 minus R. It's got to be R minus 20. Okay. Now, what else do we know? Well, we know Adam went 40 kilometers. That's a distance, all right? And Will only went 15 kilometers distance. Okay, this is the distance. Right? And then we know that Adam traveled his distance in the same time as Will. Okay, so I know Adam's time equals Will's time. That right there is an equation. Okay, equals the same time. However, do I know the times? No, I don't know the time. Okay. So what we're going to work off of is an old equation that I know you learned at some point, and that it says distance equals rate times time. Okay, how far you go, all right, can be figured out by taking how fast you're going times how long you're going. Okay, I'm going to take that and solve it for t. All right, so I divide by rate. All right. So what I'm going to do is we're going to set up an equation where we do Adam's distance, 40. And I'll write it out like this. So Adam's distance, which is 40, divided by Adam's rate, which is r, equals the distance for Will divided by the rate for Will. Okay. And he didn't go as far, he went 15, because he wasn't going as fast, r minus 20. Okay. So this is really setting their times equal, but we don't know their times. So time is distance over rate. So we have distance over rate equals distance over rate. All right, and this does not need an LCD. We can cross multiply. All right, I'll do it over here. So 15r equals, we've got 40r minus 40 times 20, that's 800. All right. Then I'll subtract, I get negative 25r equals negative 800. And you know we can't have a negative rate, but what's a negative divided by a negative? A positive, you get 32. And a rate is kilometers per hour. And that rate is for Adam. Faster guy. All right. Then each boat, the other boats, Will is, what's 32 minus 20? He's going 12 kilometers per hour. Well, nice. I mean, there's the answer. All right, speed of each. All right. Now, how long was each person driving? Time. Okay. The time is distance divided by rate, and they're going for the same time. So time, I could divide 40 by 32. Or I could divide 15 by 12, same thing. And that is 1.25. 1.25 hours. Okay. And what's 0.25 of an hour? 0.25 of an hour. Quarter of an hour is 15 minutes. So 1 hour, 15 minutes. That's for both. Each person. They had the same time. Okay. All right, here's number 1. Next one. Cold water faucet can fill a tub in 7 minutes. With both the hot and the cold running, the tub can be filled in only 5 minutes. How long will it take for the hot water faucet to fill the tub by itself? Okay. How long? All right. How long is time? So we're going to only have one variable. Here it was rate. Here it's time. And this is time for hot alone. I'm going T. Now, what else do we know? Well, that's what we don't know. What do we know? We know cold alone. No, 7 minutes. All right. The 5 minutes is if both, all right? So the time for both running, it's only 5 minutes. Okay, nice. Now, this is different from number 1, okay? Here you've got two guys, two things. Here you got 1, 2, 3, okay? You've got a hot alone, you've got a cold alone, then you've got together, okay? Time for both, all right? This is going to be an adding one, okay? But here's what you can add, okay? You can add, not their times. Like, I can't add t, time alone for the hot, plus 7 to get 5, right? We can't add the times. What we're going to add are the rates, okay? So we've got the rate for the hot alone plus the rate for the cold. That'll give us a rate for both if they work together. Okay. But I don't know the rate. Just like here, I didn't know the time or the rate. Okay. But, okay, distance equals rate times time is actually a more specific formula for a more basic formula. It says any unit of work equals how fast you do it, rate, times how long you're doing it. This is like a universal truth. It's just always true, believe it or not. Okay? How much you can do is a function of how fast you do it times how long you're doing it for. Okay? So work equals rate times time. Okay? Here, the distance was the work. Okay? Going a distance is the work. Here, filling a tub is the work. Here, painting a room is going to be the work. Any unit of work. Okay? All right? Now, we're going to take this and solve it for the rate. Here, we solve for the time. So to solve for the rate, I divide by t. So the rate is work over time. All right? So I don't know rate, so I'm going to write work over time for hot plus work over time for cold equals the work over time if they work together. Okay? Meaning both faucets work together. All right? Now, the work in this case is a tub. This is the work. A tub is 1 tub. Okay? So I have 1 over t plus, now cold's 1 tub, filling up, over time 7 minutes equals, together they're still filling 1 tub, 5 minutes. Okay? Here's my equation. Okay? Now, because there's a plus, if there's a plus or a minus, I need to find the least common denominator. Of t7 and 5, just multiply it all. 35t. Okay. So I'm going to multiply each term on both sides by 35t. Don't forget the other sign. Okay. And here, t's cancel. I get 35. Plus 35 divided by 7, 5t equals 35 divided by 5, 7t. All right, now we solve for t, subtract 5t. 35 equals 2t, divide. So what's time? 35 over 2. That's 17 and a half. 17 and a half what? Time is in minutes. 17 minutes, 30 seconds, or 17 and a half minutes. That's for what? For hot, to fill the tub alone, by itself. It's a long time. Why would it take it so long? 17 and a half minutes for the hot if it's just running hot on by itself. If the cold was on by itself, 7 minutes. But if they're both on, which typically you would think, you don't want the water too hot or too cold, it takes only 5 minutes. Why is that? Think about the rates. Okay. Anyways, number 2. 3. Anna can paint a room in 2 hours by herself. Mrs. Kranz takes 3 hours to paint the same room. Okay, this is a small room, okay. How long would it take them to paint a room working together? Oh, all right. What's the variable this time? How long to paint the room together? So that's the time. If Anna and I work together, okay, I'll call that T. All right. Time for Anna, 2 hours. Kranz, 3 hours. I'm a little slow. Take my time, though. You know, very meticulous lines, right? Painting the room. Okay. Now, how are we going to set this up? All right. We have alone time. We have alone time and together. Okay. Same setup. All right. I'm going to do rate for Anna plus rate for crayons would equal the rate if we work together. But I don't know rate, so we're going to go work over time again, plus work over time equals work over time. All right? And in this case, if there's no numbers, just like on the last one, a room is one room. Okay? So these are all just one room. Okay? So Anna's one room over 2 hours plus I in one room over 3 hours equals one room over the question mark T. Okay, so let's solve this. I need LCD of 2, 3, and T. LCD, hopefully you are saying, is 6T. Just multiply all of them. All your denominators, 2 times 3 times T. Okay. Then we'll distribute that out, and I'll get 3T plus 6 divided by 2, 2T. And then equals T's cancel, 6. 5T equals 6. T is 6/5. That's 1 1/5 hours if we work together. And what's 1/5 of an hour? What's 1/5 times 60? That's 1 hour, 12 minutes. To paint one room. If we work together. Right. Take her 2 hours alone, would take me 3 hours alone, but if we work together, just over an hour, 1 hour, 12 minutes. All right. Nice. All right, we're going to do a few more. Number 4. One pump can fill a small pool twice as fast as the second pump. Okay, so we have the first pump. Second pump. All right. Working together. The 2 pumps can fill a pool in 5 hours. How long will it take each pump alone? So we have first pump alone, second pump alone, and then together. That I know, 5 hours. Okay. So now the variable is how long T time for each pump. Right, but there's 2 pumps, but there's not 2 variables. Okay. Let's read it. Which pump is faster? First pump can fill a pool twice as fast. So the first pump is faster. Okay. So here's how we do this. The faster one will take less time. T. The slower one will be twice as slow. So it's going to take twice the time. All right. The first pump's twice as fast. So the faster one takes T. The slower one takes twice as long. Okay, second pump's slower. All right. Now, what are they doing? They're filling up the pool, one pool. So one pool each time. 1, 1, 1. Okay. So I've got 1 over T, work over time, plus 1 over 2T equals 1 over the together time, which is 5 hours. All right. It's the LCD of T, 2T, and 5. Just multiply 2T times 5, 10T. Okay. So times all the terms by 10T. And the T's cancel out first. I get 10 plus T's cancel 10 divided by 2. That's 5 equals 10 divided by 5. 2T. All right, 15 equals 2T. t is 15 halves, which is 7.5. That's 7.5 hours for pump 1. First pump. Okay, working alone. How long will it take each pump? All right. Second pump, 2 times 7.5. That's 15 hours for the slower pump. Alone. But again, only 5 hours if they work together. Okay, great power in working together. All right. Number 5. Anybody know Tom and Huck? Started a business painting fences. Specifically, they can paint Aunt Polly's fence, and they find they can paint 200 square feet of fence in 40 minutes if they work together. Right? Now, if Huck works 4 times faster than Tom, how long will it take each of them to paint 500 square feet of fence working alone? Okay. So what do we've got? We've got time, right? How long? We're looking for time. If he works alone. We've got Huck's time, alone, and together. Time. What do we know? We know they can paint Aunt Polly's fence, 200 square feet in 40 minutes if they were together. That's for how much though? 200 square feet. Okay. Now here we're getting some different work. All right. Here we've had 1, 1, 1. All right. The work's only been 1. 1, 1, 1, 1, 1, 1. All right. Now we've got some different work. This is 200 work, 40 minutes. Okay. Now when they're working alone, right, we need 500. So these are both going to be 500. Now I have to think like the last one. All right. There's not 2 variables. All right. But who's T? Let's see. Huck is 4 times faster than Tom. Huck is faster. All right. So the faster guy is going to take T. Tom is slower, and he's going to be 4T. It's going to take the slower guy 4 times as long. All right. Now rates would be Tom is R and Huck is 4R, but it doesn't ask for the rate. Okay, so I got to think about what it's asking for, time. Okay. All right. So now we can set it up. We've got Tom's work over time. So work over time, 4T, plus work, 500 over time, 4T, alone equals work, 200 over time together, 40. Okay. All right, do I need an LCD? Absolutely, I need an LCD. Now, I might, you can do this actually on the first one. You can't do it on the second one, but you can definitely do it on the third one. Let's just simplify this down a little bit. If I just divide by 10, divide the zeros out, okay? Then I just need to find the LCD of 4T, T, and 4. Okay? And that's just 4T. Okay? So instead of going like I'd have to do 40T, if I simplify it a little bit, I can get a smaller, a least common denominator, right? So that's 4T, 4T, and 4T. Okay. So what do I get? Here, the whole 4T's cancel. I get 500. Plus, here the T's cancel. So 500 times 4, that's what? 2,000, right? Equals. Now here the 4's cancel. And I get 20T. Okay, because I canceled that 0. So 20 times T, 20T. So this is 2,500 equals 20T. Let's divide it out. And how long? 2,500 divided by 20. you get 125. What's T? Time, minutes. All right. All right, now there's 60 minutes in an hour. 60 times 2, that's 120. That is 2 hours, 5 minutes. For whom? Well, for the faster one, which is Huck. And that's 500 square feet of fence. Now, Tom is 4 times as long. So we've got 125 times 4. That's 500 minutes. Or we can times by 4. That's 8 hours. 5 times 4. 20 minutes for Tom alone. 500 square feet. And you can always plug in your answer, 125, and check your solution, all right, if you want to make sure. Last one, Sam. Sam and her dad are both driving to Dayton. Okay. Sam drives her car down the day before her dad. Sam drives 200 miles in the same time it takes her dad to travel 160 miles the next day. If Sam drives an average of 15 miles per hour faster than her dad, find the average speed of each car. Okay. Then find how long was each person driving. All right. So we've been looking for time a lot recently, but this wants to know speed, which is rate. Okay. So we have Sam and Dad's rate. Now, are they going the same rate? Read it all. No, Sam drives 15 faster than Dad. Okay, so who's going to be the rate? The rate will be Dad. R. And what's 15 faster? That is adding 15, right? So R plus 15. Okay. Is there together? No, not on this one. Okay, so this wasn't alone together, right? It's just alone and alone. All right. What's their work? Well, their work is how far they're driving. So Sam's work is 200 miles. Dad, though, only went 160. So he did a little less work. Okay. All right. If we don't have alone together, I can't add anything. All right. This is the one where we're going to set the two equal because it says their times are the same. All right. So we've got time for Sam equaling time for the dad. Her dad. Right? But we don't know time. All right? But at work equals rate over time. If I solve for time, it's work over rate this time instead of work over time. So Sam's work is 200 over her rate, R plus 15. Dad is 160. He didn't go as far because he's not quite as fast. Okay. This one, do I need an LCD? No, I can just cross multiply. So 200R equals 160R plus 160 times 15. 2400. Okay. Subtract 160R, 40R equals 2400. Divide, what's the rate? 24 divided by 4. 60 miles per hour. Yes, miles per hour. That's for Dan. Okay. And then how about Sam? How fast is she going? 60 plus 15. Sam's given 75. All right, find the average speed of each car. There we go. All right, now how long was each one driving? Time Well, I could plug in 160 over plug in 60. Right? Divide, what's that give us? What's 16 divided by 6? Plug it in, what do you get? That's 2.6 repeating. That's 2 2/3 hours. Okay. And what's 2/3 of an hour? 2/3 times 60. That's 2 hours, 40 minutes. For whom? For both. Because they have the same time. Okay. All right, so these are some rational story problems. The variable's always in the denominator, okay? Good luck on these. These can take a little bit of time. You'll have an assignment in the book, and we'll work on a few more of these next time. Thanks.